Good morning. Thank you very much for tuning into my channel. Please check out some of my other videos. Anyway, today I'm going to be reading the manual for the 8-digit LED frequency counter module, model PLJ-8LED-C. And this I found when I was watching Andrew McNeil's cheap frequency counter from eBay video, and I was watching this video because I myself bought one of these off of eBay. I experimented with it a little bit and had mixed success. I was using a signal generator and I hooked that directly up to the frequency counter, and the range of the readout on the LEDs was up and down and it wasn't giving an intelligible reading, so I figured I better go back and read the manual. Well, that's too much talking already, so I'm just going to get right into reading the manual. 8-digit LED frequency counter module, model PLJ-8LED-C. User manual V1.0, Sanjian Studio, May 2014. Appendix with test details and schematics and additional notes in the main text of this manual were added in August 2016 by ZL2PD. That was page 1. Now page 2 shows the table of contents, overview, technical specifications, operation and use, product ordering, frequently asked questions, about DIY, appendix, testing and modifications. Overview. The PLJ-8LED-C module is a cost-effective 8-digit frequency counter and display module primarily to display the operating frequency in a transceiver and other equipment. It may also be used for conventional frequency measurement. The module offers compact, reliable, high performance with clear display at low cost. The main features include microchip PIC 16F648A forms the core of the 2.4 GHz frequency meter. Frequency reference using a temperature compensated voltage controlled crystal oscillator. 2.5 ppm DC TCXO. Unique gate control with precise time algorithm. No timer interrupt. Gate display refresh times include 0.01, 0.1, and 1.0 seconds to allow a real-time frequency display. Single connector input design supports 3 frequency measurement modes: low channel, high channel, and auto mode. Dual mode, I think that's intermediate frequency. Dual mode IF modes allow the offset value and the IF up-down mode to be separately preset. 8 0.56-inch high brightness LED digits with adjustable brightness. Automatic leading 0 blanking. Invalid display filter frequency selectable. Optional last bit blanking. Elegant circuit design supports 2-button control for simple operation. Settings are saved automatically and directly recalled at power up. Moving on to page 3, technical specifications. Gate time 0.1 seconds, 0.10 seconds, 1.0 seconds. 2. Channel measurement performance. Channel level high impedance. Load channel measuring range 0.1 MHz to 60 MHz. Accuracy plus or minus 100 Hz. That's for the 0.01 second gate time. Then plus or minus 10 Hz, 0.1 second gate time. Then at plus or minus 1 Hz, 1.0 second gate time. Low channel sensitivity, 0.1 MHz, 10 MHz. Sorry, that's a range. 0.1 MHz to 10 MHz, better than 60 mVpp. 10 MHz to 60 MHz, better than 60 mVpp. Millivolts per, I don't know what what's pp. 60 MHz to 75 MHz, not specified. High channel, divide by 64. Measuring range, 20 MHz to 2.4 GHz. Accuracy, plus or minus 6400 Hz, with a 0.01 second gate time. Plus or minus 640 Hz, with a 0.1 second gate time. Plus or minus 64 Hz, with a 1 second gate time. High channel sensitivity, 20 MHz to 30 MHz, better than 100 millivolts pp. 30 MHz to 60 MHz, better than 50 millivolts pp. 60 MHz to 2.4 GHz, not specified. Auto channel. Depending on the frequency of the input signal, the counter will automatically select the high or low channel. Change occurs at 60 MHz. If the input signal is greater than 60 MHz, but a weak signal level prevents automatic high channel selection, it is possible to manually select the high frequency channel. Moving on to page 4. IF settings. Independent double IF design allows the intermediate frequency settings to be adjusted in minimum increments of 100 Hz. Intermediate frequency range 0 to 99.9 repeating megahertz. Offset plus or minus IF mode can be configured. 4.4 Frequency reference. 13 MHz temperature compensated voltage controlled crystal oscillator VCTCXO in 5032 package. Frequency stability plus or minus 2.5 ppm. Supply DC input 9 volts to 15 volts with reverse polarity protection. Current 160 milliamps max. Test conditions 12 volts DC supply. Red LED display and brightness is at 8. I guess that's the test device. They used red LEDs. 6. Display. Readout. 8 7-segment LED digits. Brightness. 8 LED brightness levels. Factory set to maximum brightness. Physical. Dimensions. L times length times width times height. 125.5 millimeters, 25.5 millimeters by 21.5 millimeters. Weight 46 grams. Net weight. Interfaces. DC in. Power interface. HX 2.54 2P socket. RF in. Signal input. HX 2.54 2P socket. ICSP programming interface 2.546P pin. Moving on to page 5. Operation and use. Module arrangement. And it's got a picture of it. a front view of module, and it has the set button. And then it has a rear view of the module, which shows DC in, TCXO calibration, I think that's what CAL is, program, which maybe is like a PIC programmer, just guessing, input sensitivity, maybe a high and low, not sure what H and L is, RF in. Note, this diagram shows the high channel or channel H components on the right hand end of the board. The low channel components are located on the other side of the PCB under the LED display. Mounting dimensions. And it shows the different dimensions, which I'm not going to read. Using the module. Preparation. Please check the power supply voltage, DC 9 volts to 15 volts, and confirm the power supply polarity before use. The power supply circuit in the module has a series diode fitted to prevent operation when the power supply is inadvertently connected with reverse polarity. This protects the module from devastating consequences. Moving on to page 6. 2. The signal input 2-pin port may be connected directly to the measured signal, wired, or to an antenna, inductive mode. B. Menu structure. System settings. Red, display character. Blue, blinking character. It shows normal operation set and then the intermediate frequency value. So it's a flowchart from left to right. And then you can hit, I guess you hit the set button, maybe that's what it's saying, and it moves the digit once to the right. I think that's what's going on here. And it shows exit input frequency settings. And I guess maybe the triangle or the arrow pointing up will change the value that the cursor is on. Okay, so input frequency value is this first section, and then it goes on to a section below which seems to be called the IF offset. Add input frequency. Subtract input frequency. I guess you push the triangle button if you're going to add the IF or subtract the IF. Display equals signal frequency plus or minus intermediate frequency. Well, I don't want to add too much of my own opinion. I'm still a little bit of a novice when it comes to radio and electronics. But I know that in a super heterodyne receiver, oftentimes a carrier wave or like a radio frequency will be processed within an electronic device. And so the kind of like the working frequency that the device is working with is not the true original frequency, and it's not the final output frequency. It's like an intermediate frequency, and it's something that the receiver creates itself. So I guess, from what I gather, and I really shouldn't be speculating while I'm recording this, but you can add or subtract the intermediate frequency to maybe get the true frequency value. Just, I don't know, that's too much. I shouldn't say that. I should just read this. Exit, intermediate frequency, offset settings. Anyway, there's this third stage, which is the input, auto channel, low channel, high channel. Let's read this little box here with the dashed line around. Channel A, if input is greater than 60 megahertz, then channel L is selected, otherwise channel H is used. Channel L, select when input frequency is less than 60 megahertz. Channel H, select when input frequency is greater than 60 megahertz. Okay, moving on to page 7, filtering. So I guess the next step setting up your frequency counter is filtering. Filtering, you can have it on or off. And I'll read the dotted box. The box with the dotted line around it. On. So I guess if you set your filtering to on, input signals are input signals are less than 200 kilohertz are filtered on channel L, and less than 30 megahertz on channel H. Off signals less. I got to review greater than, less than. I remember we covered greater than and less than in grade 1. The alligator eats the greater number. Okay, sorry, once again, off when signals are less than 200 kilohertz, channel L, and less than 30 megahertz, channel H, are measured as usual. Purpose: to avoid random counting with no input signal present. Okay, because when I was testing out my frequency counter, I was getting random input numbers, random input signals. So maybe I didn't select the filtering. I'm not sure yet. Gonna have to study this a bit. Number 5, LSD mode. No LSD, J is on. Normal, J is off. On, LSD blanked. Off, normal display. Purpose: avoids chatter on LSD during 1 second channel low or 0.1 seconds high measurements. LED level 1, 2, 3, 4, up to 8. I guess that's the brightness control. Gate time adjustment 29.600.000. That's the 1 second gate time adjustment. And then there's 29.600. Okay, so it's all the same number in each of these boxes, but I guess somehow you can select between 1 second, 0.1 second, and 0.01 second. System reset, power off and power back on. So you basically reset it each time you disconnect the power. Reset completed. Okay, now moving on to selection of intermediate frequency. One of 2 intermediate frequencies may be selected by using pin 4 of the IC-SP programming interface if pin 4 is pulled high or left floating. Then the first intermediate frequency is used. If pin 4 is pulled to ground, then the second intermediate frequency is selected. Each intermediate frequency can be independently programmed with IF frequency and offset, add or subtract. The first IF settings are programmed when pin 4 is pulled high or left floating, and the second IF settings are programmed when pin 4 is pulled to ground. The default factory programming sets the floating pin 4 as the first IF configuration. If the IF is 0, then the up-down setting is ignored. In practice, pin 3, ground, and pin 4 of the ICSP programming interface, ICSP, can be connected to a 2P DuPont connector immediately adjacent or on the pins. See location circled in red below. A switch can then be connected to select the appropriate IF setting. ICSP. So there's 6 pins. Pin 1, 2, 3, 4, 5, 6. Pin 1 is the VPP. Pin 2 is 5 volts. 3 is ground. 4 is PGD/IF select. 5 is PGC and auxiliary. C. Measuring frequency. The signal to be measured should be connected to the RF-in, signal input port. The signal input can be connected to the local oscillator output from a transceiver or to other test points. Once connected, the LED display will show the frequency in real time. The high impedance input design helps to reduce the load of the counter on the local oscillator circuit in the transceiver LO. However, the signal being measured should be greater than 60 millivolts pp. For example, the oscillator signal from the widely used NE602/NE612 is weak, and the counter may not be able to obtain a stable frequency value. Moving on to page 9, product ordering. To facilitate the use of test equipment, Sangean Studios can help supply small quantities for personal purchases. Agents should go to the main page of the Taobao search engine and search for Sangean Studio or PLJ-8LED, or they can also directly contact the company. The product packaging bag is sealed with a label containing a 2-dimensional barcode. This may be scanned to load a web address to obtain product-related technical support. Product details. IC devices installed. Reflow process used. Uses double-sided plated through nickel-plated copper PCB. No power supply, no enclosure. Fully tested. Packing list. PLJ-8LED-C module in anti-static bag. 1 off. XH2.54-2P 20 cm long cable. 2 off. Precautions. 2XH2.54/2P 20 cm cables are included in the package. Please note the color polarity and connect correctly. Check the wiring polarity of the socket assembly before applying power, and read the manual before using the module to understand its operation. Do not place the instrument in hot, humid, or dusty environments, and mountings should prevent severe vibration. After module manufacturing, the reference frequency oscillator was aligned using a rubidium reference. The sensitivity adjustment has been optimized, so do not adjust unless necessary. Under normal usage, the module is covered by warranty period of 6 months. Warranty does not apply if subjected to incorrect use, modifications, or operated under abnormal conditions, which may lead to destruction of the product. I'm sorry, is there a warranty or isn't there one? FAQ. Will the frequency counter generate any interference when installed in a transceiver? Zero interference is impossible because the microcontroller, crystal, and LED driver all produce some radiated RF noise, but the level is quite low. Some measures have been taken in the design of the module to keep certain components away from the transceiver. If interference is encountered, try changing the position of the module or install a shield. What is the reason for frequency display instability? First, make sure the quality, strength, stability, etc. of the input signal meets the minimum requirements of the module. See Technical Data section. The input cable connecting to the signal should use shielded wire, and the power supply should also be suitable. Check it has no noise or ripple. Why is the display showing values when there is no input signal? Check if the ripple on the power supply being used with the module is too large. Then check whether if something near the module is generating a strong signal. The module can reject invalid signals by using signal filtering. On the low range, channel L, filtering removes invalid signals below 50 kHz and below 20 MHz. On the high range, channel H, so below 20 MHz on the high range. This will then result in the normal display showing 0 with no input signal. Since the display is limited to 8 digits, how can it display the hundreds of megahertz and gigahertz digits with 0.1 seconds and 1 second gate times? By reducing the gate time or using the LSD function, it is possible to obtain a suitable frequency display. For example, when measuring 450 MHz, when the LSD is off, see menu setup section above. 1 second gate display, 50.000.000. 0.1 second gate display, 450. When the LSD is on, 1 second gate display shows 450.1 second gate display, 450.000, etc. When measuring a 2400 megahertz signal, so 2.4 gig, when the LSD is off, 1 second gate display shows 0. 0.1 second gate display shows 400. When LSD is on, 1 second gate display shows 400. With the 0.1 second gate display, it shows 2400. So, I don't know, I need to study this better, but it sounds like depending on the settings of the gate display, this is what you should see. Okay, page 11, do-it-yourself options. A full set of manufacturing information on the PLJ-8LED-C was released on a forum which can be sent directly to a PCB Gerber file processing plant. The software is available as a hex file suitable for most microprocessor programmers without manual intervention. If your programmer doesn't recognize the settings, the crystal type can be selected and the remaining options simply turned off. A summary of the conditions covering this software and which limits its use are found in the programming document released by the forum. When you power on the 25th time, the counter will display that. To remove these restrictions and continue to use the counter, carry out a system reset to recover. Press and hold the set during boot up. There are no other hardware or software traps. What does that mean? Attachments containing the frequency meter for previous releases can be found on the hellocq.net forum as follows. All intellectual property rights contained in this product are property of... Well, anyway, moving on to page 12, Appendix. Testing and modifications. Accuracy. The accuracy of the measured frequency was tested by F6CQK using an epoch quartz oscillator. Sounds like a ham radio guy. Calibrated from a rubidium clock. This showed an error of -10 Hz. This was easily corrected using the calibration adjustment available near the TCXO. A measurement over 24 hours shows a stability better than 1 Hz. Sensitivity of the module was measured by F6KEH shown below. high channel CHH shows the dBm measured against the frequency. Schematic and modifications. It is noted that the UHF channel allows measurements up to about 450 MHz. This path compromises a divide by 64 stage claimed to be able to operate to 2.4 GHz according to the published specifications. It is therefore surprising that the sensitivity fell as quickly as it did. The problem could come from the automatic channel switching. Unfortunately, no schematic is provided in the Chinese instructions. However, elsewhere a circuit for the front end was located. And then I guess you could study the MB506 Prescaler circuit. This shows a conventional preamplifier for each channel paralleled at the input. Each channel uses a dual gate MOSFET as a preamplifier followed by a buffer stage, CHL, or divider buffer, CHH. The buffer transistors in each channel are used to obtain a TTL level. This somewhat agricultural approach suggests that the low channel is likely to be excessively loading the higher channel, and that it is precisely what we see in the French sensitivity results. It's like a bad translation, apparently. That's not making any sense. French sensitivity results. What does that mean? The ideal solution to this is to separate out the two inputs and connect them to two separate input connectors, one for each channel. Note, the high channel, including Prescaler, is located on the visible side of the PCB adjacent to the PIC microprocessor and TM1639 LED display driver. The low channel is not visible. It is located under the left hand from panel LED display when the module is viewed from the front and is connected to the input connector and microcontroller via through-plated holes in the PCB. Number 4, channel switching reliability. The manual notes, see above, that the automatic channel switching does not always work reliably for low frequencies above 30 MHz. In this case, it is best to manually select the range. For frequencies above 100 MHz, the hundreds digit may not be displayed sometimes. In this case, press the triangle button to select the appropriate gate time until the hundreds digit is displayed. Well, I have an opinion, like a well-manufactured product and a well-designed product should not require so many technical adjustments. It should almost work right when you start operating and using it. And I don't know.